Welcome to the week of May 10th. This is your geometry recording of the week, and it's actually going to be your last recorded session for the school year. There won't be one next week, so that's pretty exciting. We are getting so close to the end of the school year. So take a moment to think about everything you've learned this year and every assignment you've submitted and just how far you've come. You guys have done a lot this year and you should have a lot to feel proud and accomplished by. So I just wanted to mention that and say good work to all of you guys. We aren't quite at the end of the school year, so hang on a little bit more for just, I think we've got about 2 more weeks left. So hang out and hang in there for the last 2 weeks and finish strong. Finish strong for these last 2 weeks. I did want to start this recording with a warm-up question. So at this time, make sure you've got your math notebook out, and then I would like for you to take point to -3, and I want you to transform that in 2 different ways. So the first transformation that you're going to do with that point is take that point to -3 and horizontally translate it 5 units. So I'd like you to do a horizontal translation of 5, and I need to put a direction in there. So let's move that to the right. Let's say a horizontal translation of 5, 5 units right. I forgot to put that in there. And then we are going to do a vertical translation of that same point and move it -1. So vertical translation of -1. So 2 different movements. The first one is separate from the second one. So just to get you thinking about what we did last week, and then we're going to continue on with that theme this week. So if you need some time, go ahead and click pause so that you can try this in your math notebook, and when you're ready to check your work with mine, go ahead and click play. All right, so since we're moving, the first translation is a horizontal movement 5 units right. So that means we were going to have a new point. We're going to add 2 and 5, 2 plus 5 for that movement to the right 5 units. And we're not moving it horizontally or vertically, so that's going to stay the same. So then we would just add 2 to 5, and that would become 7. So our new coordinate would be 7, -3. And you can actually plot that on a coordinate plane if you would like to do that to check your work. So we'll do that really quick here. We've got a coordinate plane. The original point is at 2, -3. So that's right here, 2, -3. And then we're going to move it to the right 1, 2, 3, 4, 5 units. So 1, 2, 3, 4, 5 units to the right. So that's going to be our new point. So we go from our original point and move it 1, 2, 3, 4, 5 units to the right. And there we get our coordinates of 7, -3. Now let's take the same point, the original point, and then let's move it a vertical translation of -1. So now we're taking that original point and moving it down 1. So we're just moving it down 1. That's all we're doing, is taking that original point and moving it down 1. So what would be our new coordinates of that point? Well, again, we're just changing the y coordinates. So when we have a vertical translation, we just change the y coordinate. Our x coordinate will stay 2, and then we're going to take that original coordinate, -3, and take 1 away. So when we take -3 minus 1, we get -4. So I'm just going to change that to -4. And we can see that that is what the coordinates are when we move that down on the actual coordinate plane. it would be, oops, not -2, just +2. Marks that point. All right, so let's talk about some exciting stuff. We, again, are only 2 weeks away from the end of the school year, so that is exciting. It's also, I keep reminding you guys how far away we are. For those of you who might have some missing assignments, you need to be working on those now. Remember, you need a 60% or higher to pass this course. If you don't pass it, you will have to retake it. So that's not a good thing. You've spent so much time and energy already in this class. I'd like you to really focus on passing it so that you can be done and move on to your next math course. Also, whoops, redos and late work. I just wanted to remind everybody that if you do submit late work, you do have to send me a message. If you submit late work, you need to submit a message to me. Just send me a message to get it graded. Remember, you do need that to get it graded. If you don't, there's a good chance it won't get graded because Schoology doesn't alert me about submissions of late assignments. So be an advocate for yourself. It's really quick to send me a quick message that says, hey, Miss Cole, I got this assignment done. And then remember, since we are now working in Unit 9, that is the only unit you should be doing redos for. So I only accept redos from the current unit we're in. We're in Unit 9, so that is what I'm accepting for redos at this time. And remember, when you do a redo, you also have to send me a message to let me know. All right, so this week, we're going to complete the last 2 sessions for the year. Next week, there's going to be a quiz, and that'll be your final assessment is a quiz over this. But this week, it's kind of cool. We're learning the last bit of new information for the school year. We're going to do sessions 2 and 3, where we're going to take a look at some parent functions. And then in session 3, how we can transform parent functions and linear functions. So let's dive right in. What are parent functions? So a parent function is just a function with no transformation associated with it. So we're going to look at some parent functions that have a specific graph associated with it. One of them that you guys are familiar with is linear equations. And linear equations, we know what they look like when it's graphed. So a linear equation is something like y equals mx plus b, and when we graph it, we get a line. So the parent function for a linear equation is going to be, I changed my color font here, it's going to just be y equals x. That is the parent function for a linear function. And when we graph that, I'm going to put some coordinate planes in here really quick. So when we graph a linear equation y equals x, we get a diagonal line. So y equals x, that means like if you put in 0 for y, x would also have to equal 0. If we put 1 in for y, x would also have to equal 1. If we put in 2 for y, x would have to equal 2. So we could plot each of those points, and we're going to get a diagonal line. I'm going to get a diagonal line. I wanted to do that in blue. So that is what the parent function for a linear function would look like. The equation is going to be y equals x, and when we graph it, we're going to get that line, that diagonal line. Quadratic equations, or quadratic functions, is going to be, oops, and I should have put not y equals x, because we know for function, we don't put y in there. We like to put f of x in there, so I should change that. It's our fancy way of writing when we do functions. So for quadratic, we're going to have f of x, and remember that whatever number we put into the parentheses tells us that whenever we see that an x, we put that number in. So that's what a function is. So the quadratic parent function is going to be f of x equals x squared. And when we graph x squared, we're going to get a U shape. We get a nice U shape for quadratics. A quadratic function, the parent function, always passes through 0, 0, and we get this nice U shape. I'm going to continue on. The cubic function is going to be f of x. Remember, we put f of x instead of y equals. And the cubic, anything cubed, is x cubed. And when we graph a cubic function, again, we pass through 0, 0, and we kind of get this weird little S shape. So again, that passes through 0, 0. I'm doing my best to get these graphs in there right. All right, and then the square root function is when we have f of x equals, you got it, the square root of x. And we're always going to get this shape here when we graph a square root function. So you guys should just start being familiar with what these parent functions look like when we graph them and their shapes. So take a moment to look at this again so that you're familiar with the parent functions and what their graphs look like. So the parent functions are always going to have this shape of these graphs. And then we're going to take it a step further this week, and we're going to start applying transformations to each of these graphs. We're going to move them vertically, horizontally, and we'll stretch and do compressions to each of these. So this is what each of the parent functions look like. I'm going to move on now. So parent functions, we just talked about all the different parent functions for linear, quadratic, cubic, and a square root. So we now are going to look at the different parent functions and see if we can describe the transformations. So I'm going to be explaining what the transformations are and what they look like when we apply them to the equations. So looking at this equation, does any piece of this equation look like the parent function from the previous screen? Look right here, y equals x. That is one of our parent functions. And that would be considered a linear function. So the parent function would be a linear function. And then the only difference is that now we've got this plus 3. We've got this plus 3. And we can actually graph this to see what happens. What is the transformation? So let's go ahead and graph this. So let's graph the parent function. We know the parent function is y equals x. That's what our parent function would be, is just y equals x, which we know looks like that diagonal line. So there's our parent function, the y equals x. I just graphed that right here. So this is y equals x. Now let's graph it when we add the plus 3. So if you want, you can make a little table to help us. So if x equals 0, we add 0 for x. What does y equal? 0 plus 3 is 3. So when x equals 0, y would equal 3. What about when x equals 1? When x equals 1, we've got x plus 3, or 1 plus 3 equals 4. What about it when it's 2? When x equals 2, we've got 2 plus 3, which give us a y value of 5. So let's plot these points now. 1, 2, 2, 3, 4, 5, 1, 4, and then 0, 3. So that's my rough sketch there. So we'll graph that now. Whoops, a little bit high, didn't quite go through. There we go. So what did we do here? What is that plus 3? What did it do to the graph? What did that plus 3 do to the graph? Well, that plus 3 just moved our graph up 3 units. So if we look, it just moved our graph up 3 units. So we're going up from our original graph. We just moved our graph up 3 units. So the transformation is that we moved up 3 units. We moved a vertical up 3 units. So that was a transformation. So the parent function was originally that y equals x. And when we have that plus 3 at the end, that tells us that we are moving that graph up 3 units. All right. What about this function here? This equation is y equals x cubed plus 1. So what is our parent function? Our parent function is just right here, the y equals x cubed. It's a cubic function. And then we've got the same thing where we've got a plus 1 at the end of our equation, which means we're going to do that same thing we did before. We're going to take it, and it's going to be a vertical translation, because when we move stuff up, it's just translation of up 1 unit. So we're taking the whole graph and we're moving it up 1 unit. I'm going to go to the next slide. What about one more? So here we're not going to talk about the transformation. I just want you to tell me what the parent function is. What do you think the parent function is? So here I see that there's a squared and an x. So that is what the parent function is it's going to be y equals x squared. It's a quadratic. It's a quadratic function. So y equals x squared would be our parent function. We also have, let's talk about the movements here. So we see this plus 3 at the end, and I'm just going to tell you what that means. Again, that's going to be we're going to take that parent function and move it up 3 units. And then we also have in parentheses, so if you look and you look closely, in the parentheses we've got x minus 1. And that x minus 1 is actually going to tell us a horizontal movement. It's going to tell us a horizontal movement, horizontal translation, and it's actually going right 1 unit. So I know that seems weird because usually x minus 1, you would think it's going to the left, but anytime we have horizontal movements, it's always going to be in the parentheses and grouped with that x, and it's going to be opposite of what you think it is. And we'll talk about why that is in just a moment. So usually one would think that x minus 1 would mean that we're going to the left, but in the actuality, when we're talking about horizontal movement, it's opposite of what you think it would be. So x minus 1 in parentheses grouped with that x is actually telling us we're going to go to the right 1 unit to the right. So I'm going to go on to the next slide. We're going to talk more about those horizontal and vertical movements. All right. Oh, before we do that, here is like an example of a problem that you're going to see in Unit 9, Session 2, where we're given an x and y chart, and we need to plot those points and figure out which parent function that best represents the data set. So let's figure out what the parent function would look like, or what it would be. All right, so let's plot the points. 0, 2, I'm going to plot that point. 1, 3, we're going to plot that point. 2 and 3.4, so somewhere between 3 and 4. We've got 4 and 4, and then we've got 9 and 5. So not a straight line. There's definitely not a straight line. If we connect these, we're curving a little bit. So what does that remind you of when we did all the parent functions? When you have a graph that kind of curves out. It starts and it curves. If you said a square root function, you are correct. So this would be a square root function. This data set represents a square root function. There has been a transformation. We have taken it, because remember the parent function of a square root starts at 0 and goes out like that. So we definitely have had a little bit of a movement. So it looks like we've taken this graph and moved it up 2 units. So if I look at the original where we start, and now we're starting at 2, that looks like we just took the function and we're moving it up 2 units vertically. I'm going to go on to the next slide. So let's talk about some different types of translations. That is what session 3 is all about, is how we can take a parent function and move it. So one of the ways we could take a parent function and move it is to move it horizontally. So here's our linear parent function in blue here. It represents y equals x, and then we can move it horizontally. And to show a horizontal movement, we attach it to the x, and we attach it in parentheses. So here's what I was talking about when we have horizontal movements, and that when it's in parentheses, it's kind of opposite of what we think it would be. So here we've got x minus h, and h is going to represent that horizontal movement. If h is greater than 0, that means we move it to the right. So remember, it's always x minus, kind of like with circles last week. It was x minus for the center of, so the same thing here, it's x minus. So if we have a positive h, that means we move right. If we have a negative, it's going to create that double negative there, which would actually make it a positive. So if you have an x minus negative h, so if we have a negative h, remember that's going to turn it in, a double negative becomes positive. So this would tell us we're going left. Whereas if we have x minus h, that tells us we're going right by however many units h is. So let's look at an example here. Let g of x be the indicated transformation of h of x. So we're going to take a parent function of f of x, and we're going to transform it. And then the new equation is going to be given with g of x. So our parent equation will be represented with f of x, and then we're going to use g of x to represent that transformed equation. So let's see here. Our original parent function is f of x equals x minus 2. And we want to translate that 3 units to the right. All right, so let's see how that's going to look. So we're going to have g of x equals, whenever we have a function and we move it to the right or left, a horizontal movement, we'll group it f of x, we're going to do x, and we're going to the right, so it's going to be x minus 3. So that's what it's going to look like. So now, anytime we see an x, we know we need to plug in that x minus 3. So now we're going to have, our parent function is x minus 2. So whenever I see an x, I'm going to plug in this horizontal movement, and then I'm going to apply that negative 2. So remember, our parent function is up here. And whenever I saw that x, I plugged in that x minus 3, and that's how I got this equation. So now I'm just going to clean that equation up, and g of x is going to equal x. Negative 3 minus 3 is negative 5, or minus 5. So that would be our translated new equation. And this is what Unit 9 Session 3 is all about. So you guys are going to have to look through and watch the videos carefully to learn about horizontal shifts and horizontal and vertical stretches and compressions. So I'm gonna skip through a lot of Unit 9 Session 3 just for time's sake. I don't want this recording to get too long. And I just want you to make sure that you go through those videos very carefully in Unit 9, Session 3. So that brings us to the key phrase assignment. So let me get that written in for you. So I have put up a graph of a parent function that you learned about today. So what parent function represents this graph? And that is your key phrase. So again, I did not have time to go over all of Unit 8, Session 7. I want to keep this recording as short as possible. So please make sure that you're taking your time when you go through Unit 8, Unit 9. I don't know why I keep saying Unit 8. Unit 9, Session 2, and Session 3 this week. And that's a wrap. So have a wonderful rest of your week. And as always, let me know if you need any help as you're working through the assignments this week. Have a wonderful rest of your week.